Have you ever heard of the 8 queens problem? It's a chess puzzle that was first proposed in 1848 by Max Bezel, a German chess composer. The goal is to place 8 queens on a standard 8x8 chessboard so that no 2 queens attack each other. In other words, no 2 queens can share the same row, column, or diagonal. This problem has 92 distinct solutions. However, if you eliminate symmetrical duplicates, meaning rotations and reflections, you only have 12 unique solutions. Here, I show you a typical solution of the problem. Now I have some challenges for you. If you are a chess player, you can find solutions of the problem using your chess experience. If you have experience in programming, you can build a code that solves the problem. For this challenge, I propose Python as it is a quite simple and powerful language, where you can easily build your own algorithms. Last but not least, if you are a math enthusiast, you can find an algorithm that solves the problem using mathematical proofs. Now that we've cracked how the 8 queens puzzle works, let's take a step back. We're going to hop into a time machine, spin the dial all the way back to the year 1848, the year when Max Bezel published the problem. In 1848, even though the rules of chess were the same as we know them today, the pieces were far different, as they followed old European or English style, which dominated in the previous centuries. There were sets such as the Barleycorn, the St. George's set and the Salinas style set. The result was that players from different nations struggled to recognize the pieces. The idea of the 8 queens puzzle though was very recognizable and practical. As a result, in the next year that the Staunton set was established, the problem became known worldwide. 1 year later, it became a mathematical problem and Franz Knock, a chess enthusiast, generalized the problem to n queens on an n times n board, now known as the n queens problem. Thanks to this problem, backtracking algorithms were created that are also used for solving problems like Sudoku, crosswords, and scheduling. A fun fact is that the 8 queens problem has been extended into 3D chessboards, hexagonal boards, and even torus boards, where the board wraps around like a donut. And now the question is, can you find the 12 solutions of the 8 queens problem? Anyway, don't miss the chance to subscribe my channel, where you can find lots of interesting things about riddles and chess.